So I am planning to discuss all of the unscorable problems in Div1 and the first four problems which I managed to solve in the contest. And like unfortunately I could not solve that lexicographically within time. So I will probably end up skipping this problem. Before we get started, can anyone confirm if audio and everything is fine? Like like it was first rated for all contest. Like the previous rated for all contest was around in first week of January. So like this is the rated contest I have after last 6 months. Okay, so let's start now. So I will start with first three problems. This one says capital gain tax, the annual budget of Serglat has been announced and people are concerned about modification is capital gain tax. Given that capital gain tax changes from X% to 5%, find whether it has increased, decreased, or has remained same. So what it asks us is if we have to compare X and Y, and based on their difference, we should print increased, decreased, or same. So like the way we can do it is like probably we can read two integers first. In that, if X is less than Y, means like the tax has increased, and if X is less than Y, it means if X is greater than Y, it means the tax has decreased. So like this would be the solution for this problem. So essentially this was the solution for the first problem, capital gain tax. Savings account, considering the new budget, SAF decides to keep all his money in a savings account. SAF has X income sources where he gets Y rupees from each source. However, due to bank restrictions, SAF can keep at most Z rupees in savings bank. What is the minimum number of income sources SAF should reduce to maximize saving without exceeding account limit? Okay, wait 1 second. Like, let's look at the explanation. It says XYZ, but it's a bit confusing. Like X income sources, and he gets Y rupees from each source, and it says we can keep at most Z rupees in the savings account. What is the minimum number of income sources should reduce to maximize his saving without exceeding the account limit? Probably let me first try to see what's going on here, but and then XYZ. Not really sure if I understood the problem correctly, but I just went ahead and submitted it. Or wait, it should be Jadbaba. Because like this is the first time I'm reading and I'm directly trying to submit something. 1 second. Let's see the samples. Saif can store a maximum of 4 rupees in the bank account. He has one income source from where he gets 2 rupees. Since the total income is not more than the amount limited, he does not need to decrease his limit. Saif can store 6 rupees in the bank. He has income sources from where he can get 4 rupees each. Currently, total income is more than the limit. Saif will reduce one income amount. So the total lies within 1 second. Okay, I forgot to read the number of tiles. Okay. Yeah. So what this problem statement says is we have X bank accounts which each of them has total Y rupees. We have such a X accounts, and in bank we can only keep Z rupees. And it asks us like how many accounts should we remove from here. First thing first, let's first find how many bank accounts we can keep. Okay, keep. The idea would be like we would have one bank account with Y rupees, another bank account with Y rupees, another bank account with Y rupees, and so on. And we can keep maximum of Z by Y bank accounts. And originally we only have X bank accounts. So minimum of X comma Z by Y would be final bank account number. Final count. So number of accounts which I have to remove would be X minus this, the total I can keep. And like essentially that would be the solution here. Total account we can keep would be minimum of X comma X is the number of accounts we have, and Z by Y is the limit because each account has Y amount. So finally we need is would be X minus account P. And essentially this would be the solution for this problem. I am moving one after the other. Like my plan was to first discuss the three problems and then I will move to the larger scale. And essentially any questions on this one, savings account, before we move on to budget allotment? This year's annual budget involved a discussion on N sector where each sector was initially allocated an amount AI. It was later realized that a minimum budget of X is required by each sector. Allocation can be transferred from sector I to any sector J. Only final allocation of sector I remains at least J. Find the maximum number of sectors that can meet the minimum budget requirement budget of X after proper transfers. Okay, so the idea would be like we can look at the total amount. Like first we can try to find. Mhm. So here my idea would be we know like the amount for each sector, right? A1, A2, A3, A4, and so on. So idea would be like we cannot transfer money from any sector which has less than X amount because X is the budget we need. So what we will do is like we first look at or like the other way I see is like one- the idea would be like we can first keep the numbers in decreasing order such that A1 is greater than A2 is greater than A3 is greater than so on until A. And now in this order, if any sector has more than X budget, we maintain a extra count, a variable count or some whatever we call. If it's greater than X, we will transfer all A2 minus X budget to this sum. And if the current number has less than X, then we will see like what is the extra required, which would be X minus A3. And if we can get that number from the sum, we will get it and increment our I by plus 1. If we cannot get that, we will just make a break there. The idea is start greedily. First look at all the sectors which have more than X budget, and from that get the total extra money you can get to transfer to something else. Now for all the budgets which are less than X, count how many of them less than X, pick the largest one because that would be the one which would need minimum amount to get least the limit X. So like find the largest, give that whatever delta it needs, and then go to the another number, and then keep going it in this order, and that would be essentially the solution for this problem. And like greedy everywhere is the solution. One second, I will probably end up. It was budget 25. Read all the numbers, n and x, and all the numbers. Sort everything in reverse order. If current budget is greater than equal to 0, answer plus plus, and sum plus equal to z minus x. Like this is the extra amount we have. Otherwise, the extra rec would be x minus z. If the extra required is less than equal to any budget we have, answer plus plus sum minus equal to extra required. This would be the idea for the first three problems. Any questions on first three problem before we move on to the other Div1 problems which are rated for Div1, and I have the questions ready for this. Any questions so far? Before we move to larger scale, like any question on these three problems? Okay, no doubt so far. Okay, I will move to the larger scale now. It says you are given an integer array A of size n. Find the largest integer k such that there exists a subsequence s of length k where k is divisible by number of distinct elements in S. The statement is short and sweet. What the statement says to us is we have been given an array A1, A2, A3 up to AN. Find the largest k numbers. Find the largest integer k such that we can choose k numbers from here. Let's say these are the 4 numbers we have chosen. Let's say A1, A7, A10, A20. Now the next thing it asks us is count the number of distinct elements here. Distinct elements. Like if we have chosen 4 numbers, then the number of distinct elements can be all 4 numbers are same, or like there are only 2 different numbers. Like for example 1, 2, 2, 1, or the array is 1, 1, 1, 2, something like that. Or there can be 3 different numbers like 1, 2, 4, 4, something like that. Or there all 4 numbers can be different. Like if you choose 4 numbers, then the count of different distinct numbers among those 4 numbers would be 1, 2, 3, 4. It asks us to say like for this sequence of sequence A1, A7, A10, A20 to be valid, the number of distinct elements should be divisible by 4. That is 4 is allowed, 3 is not allowed, 2 is allowed, 1 is allowed. So probably to summarize the problem statement again, we have to find maximum possible k such that we choose k different numbers from the original array. And if we look at distinct count of those k numbers, let's say the sequence is b1, b2 up to bk. Let this be L. Then L should be divisor of k. Any questions on the problem statement before we try to find out like what should be the value of k? Okay, problem, like I will probably summarize again. Let's say we have original sequence, like let's say we have 20 numbers, A1, A2 up to A20. We will call a sequence valid. Like let's say we have chosen some numbers B1, B2, B4, B3, B4, like these are the numbers, B5, B6. Like this basically means like let's say we have chosen some 6 numbers from this. This is B1, this is B2, this is B3, some number here is B4, some number here is B5, and some number here is B6. Now we have to count how many different numbers are there. Or probably I think it would be better if I take one of the samples here. Let me just pick a sample here. Can you give me an array of length 6 or length 7, let's say? Can you give me an array of length 7 or 8, any random array? And Okay, 1, 5, 2, 4, 1, 4, 6, 4. Now let's look at some different. Like, let's pick some random numbers from here to see what, like, let's choose this as one of the sequence. 5, 4, 4, 6. Total number of different elements you can see is 3. Okay, like total number of different element is 3 different elements, and total length is 4. And because 3 does not divide 4, the number is not valid, invalid sequence. And probably let's choose some other sequence. Let's say 1, 1, 4, 4, 1, 4, 1, 1, 4, 4. You can see like number of different elements here is 2 different elements, and total elements are 4 chosen elements. So this is a valid sequence. Or probably we can do something better here. Like let's choose 1, 5, 2, 4, 6. 1, 5, 2, 4, 6. Total different elements here are 5, and length of chosen element is 5. Because 5 divides 5, this is also a valid sequence. So the way we define a valid sequence is like we choose some number of elements from there. Then we count how many different elements we have chosen and what is the count of total elements we have chosen. If this divides the other element, we say that sequence is a valid sequence. Otherwise, we say that sequence is not a valid sequence. And the question asks us to find length, find maximum length of valid sequence. In this case, like 1144 is also a valid sequence, and this 15424 is a valid sequence, but here the length is 4, here the length is 5. So in this case, the answer here would be 5. And like this is the problem statement. Any questions on the problem statement before we move on to the solution? Okay, yeah. So now I will move on to solution. My idea is like, first of all, only the count of elements matter. Like I don't really care what elements are given in the sequence to me. Like for example, let's fix the number of different elements we want. 1, 2, 4, 1, 2, 4, 1, 4, 4. Yeah, this is also a valid sequence. Total different of number elements are 3 and total count is 6. So the answer for that example would be 6 instead of 5. Sorry, my mistake. Like I did not look at it closely, but yeah. So basically don't choose 5 and choose everything else. You will get what we need here. Good call out, Swastik. Yeah. So what I will do is I will first fix number of different elements we want. We can iterate this from like k equal to 1 to maximum distinct count we have, like whatever like different elements are there on. And let's say we want 3 different elements. Then what is the maximum length we can have? Let's forget the divisibility part. If we want 3 different elements, what is the maximum length we can have? I claim like the maximum length we would have is take the number which like for example, let's say we have a sequence where 2 appears 4 times, 3 appears 1 time, 5 appears 6 times, 7 appears 12 times, 9 appears 8 times. Let's say we have this sequence. And if we have to choose 3 elements and get the maximum length, let's even forget about divisibility part. Then my claim is choose the ones which appear maximum time. Like choose 7, choose 8, choose 6. These are the ones which appear maximum time. So you get a sequence of 6 plus 12 plus 8, which is around 26. And this number is not divisible by 3 although. So the next idea would be to remove some elements from here. Like because like the largest number divisible by 3 which is less than 26 would be 24. So what we can do is like we can just ignore 2 numbers from here. So in this case, like we can get a sequence with 24 numbers. We can get a sequence with 24 numbers, which has only 3 different numbers. And that is my idea. And if we iterate on all such values of k from 1 to maximum number of elements we have, we would get our final answer. And essentially this was the solution for this problem. Like for each element, count number of times they appear. So we have maximum element to compensate the modulo and number of distinct element remains same. Yes. So my idea is, let's say this is the example I have chosen. We have a sequence where 2 appears 4 times, 3 appear 1 time, 5 appear 6 times, 7 appear 12 times, 9 appear 8 times. So my idea is, first I will count what is the maximum length of sequence I can get using only one element, and the answer would be 12. Like one distinct element, maximum sequence length I can get is 12. So and now I am iterating on the number of distinct elements I would have in a sequence. And now if I have 2 distinct elements, now next I iterate on like what is the maximum length of sequence I can get using 2 distinct elements. That would be when I choose 12 and 8, which is 20, and choosing all 12 is fine because 12 is divisible by 1. So I say answer equal to answer max of answer comma 12. Now here like this 20 is also divisible by 2. So I will say answer equal to max of answer comma 23. Now let's see if I want to choose 3 distinct elements. Maximum length if I have 3 distinct elements would be when I choose the number which appears largest 3 times, 6, 12 and 8. Which in case is 26, and 26 is not divisible by 3. So we try to find what is the largest number which is multiple of 3 less than 26, which would be like 24 here. So now I will do answer equal to max of answer comma 24. Now I say if I want 4 distinct elements, the idea would be I choose the one which appears 12 times, 8 times, 6 times, 4 times. 12, 8, 6, 4, which would be 30. And the largest multiple of 4 less than 30 would be 28. So I will do answer equal to max of answer comma 28. The idea here is like I can remove any 2 numbers from here as long as every number remains at least once. In that case, like for example here what I can do is like instead of taking 7 12 times, I take 7 10 times. That is one possible solution. That would be the solution for this as well. And that is the idea. Like first fix the number of different elements you want. Now try to make the longest sequence you can get using those many distinct elements. Now try to remove some elements from the top as long as all the numbers are not divisible by that number. Yeah, this is 12 plus 8, which is 20. And once you are now, like, the next is, what if I want 5 distinct elements? In that case, I would end up taking all the elements 4, 1, 6, 12, 20, which would be around 31. And the largest multiple of 5 which is less than equal to 31 would be 30. So I will do answer equal to max of answer comma 30. And that is the main idea for this problem. So this was my solution here. Like, the idea is, like, first I take n as input, then I take all the integers as input, and now I have frequency array where I keep frequency of all the elements. Now, because I don't really care about the element here, all I need is how many different elements are there. So I have created a new vector v which contains frequency of all the elements I have. Yeah, we can guarantee everyone comes at least one time, because when we are choosing, we would choose only those elements which are at least one time, right? If you even remove everything, like for example, if you have 5 and you got sum as 9, because you took 5 numbers which appears at least one, everything will remain at least once there. Because the optimal is, like, you can just take all the instead of taking multiple frequencies of each element, you just take each element once. That is the minimum possible you can get, and the answer would be 5 there. Like, that you can, how to decide, you can just use greedy. You can choose the number which appears maximum number of times and decrease that by 1. Then again look at what is the number which appears maximum number of time and decrease that element by 1, and you can keep doing it. It's guaranteed that when you will make it a multiple of elements there, it would be the element there. And in theory, you don't really need to exactly remove it. Like, you can just assume that there would be a way to get that maximum element. So now I have sorted the frequencies of all the elements in distinct order. Now I am increasing d dot size. Now, like, for sum equal to, I will do bk minus 1. It's because it's 0 based indexing. Now what we can do is, like, we can just look at reminder here. Largest multiple would be, like, whatever sum you have got minus remove the remainder. Largest multiple you can get. And that would be so, like, one more question, how can we find the maximum length of subsequence where sum of subsequence is divisible by length of subsequence? Like, I don't think we can solve it for generic constraint. Like, one way can be, like, we can define a DP as up to index I, we have chosen k elements, and this is S is their sum. Like, we can define a DP like this, and then we would have to look at dpn for all the values of I equal to 1 to n, and all the S we have got, all the multiples of I, see if that is valid or not. And that can be one way to do it. Like, yeah, like, that is also correct. Like, total chosen element divided by total chosen distinct element will always be at least the minimum frequency of any element in the chosen sequence, right? And yeah, like, that would be another way to look at it. And because that minimum sequence is at least 1, so you will be able to get everything. So any questions on larger scale before we move on to the next problem? Like that essentially depends, variation of this problem depends on the constraint, like how the constraints are. Like, based on the different constraint, you can tweak it around into different ways. So like I will now move on to the next problem. It says minimum inversion. You are given a binary string s of length n and an integer k. You can flip at most k characters of string s. Find the minimum number of inversions in the final string. Like basically during a flip, you can change a 0 to 1 and a vice versa, and a pair of indexes I to j is said to be inversion if this holds. Like the remainder will always be present because like you will like if you choose 5 numbers, you will have at least one different element. Like the idea is you remove element with the largest frequency and you keep doing it one by one to get all the numbers you want. Yeah, like it was rated for Div1, so like it was a normal contest, I would say. Like in normal code forces as well, like in Div1, I can't solve the harder problems, so that's fine. So like the problem statement says, first let's see what is inversions here. Before even we minimize or we do some operations, let's say we are being given a binary string 0 1 1 0 0 1 1 0. Here it says count the number of indexes such that I is less than 0 and Si is greater than S0. And if you look at if it's binary number, all the elements are 0 and 1 only. So if so Si must be 1 and Sj must be 0. So what it essentially asks us to do is count the number of pairs I less than j such that Si equal to 1, Sj equal to 0, and that would be the count of inversions. Any questions here first? No, continuous is not given in the problem statement. It just says subsequence. Like so like that is the problem statement. Any questions on the problem statement? Now it says we have been given some sequence S. We can change at max k numbers from that sequence such that number of inversions should be minimum here. And now we have to find that minimum count here. Any questions? Like any questions on the problem statement here? Like how do we define inversions here? How do we define inversions here? And then another question was then the question was after doing operations we do something here. Yeah, like some people in the chat pointed out like I tested this problem 2 years ago. Like I would say like this idea of counting inversions in a subsequence is also present in Editorial library as well. So like probably not something difficult. Like, here also it's counting a binary sequence. If you look at this as a practice task, you are given a sequence as no 1 second. Ransom not. You are given binary array q queries, like basically change some sequence here and count the number of inversions in subsequence. So if you just copy paste this template here, like you don't need this replace operation here. So you would be able to count the number of inversions in a subsequence there. Yeah, like this is probably I would be answering all those questions when I'm done with the layer. Yeah, I can send like once I'm done with all the discussions, you can ask about all these questions, which site it is, where to practice DP and all. I would be try to answer them. So like or just Google on Editorial library. Like there are more sites where you can practice alone. Yeah. So let's get back to the basics first. Let's say we have S1, S2 up to Sn minus 1 as the original sequence. Now we want to change k numbers here, and after that we will count the maximum frequency here. So let's make some observations first. That will make our life a bit easier. Let's say this is 1, 0, 1, 1, 0, 0, 1, 1, 0, 0. Let's say this is our sequence here. And let's say you have done some modifications, and one of the modifications was changing this 1 to 0. And you did not change anything here. This one remains 1. And after some modification, let's say you have modified this, you have modified this, you have modified this, and something. And in one of the operation, you have changed this 1 to this 0, but this one still remains 1. So my idea is, like, for number of elements where this is a part of inversion is count of 0 after this. And here also it says, like, number of inversions which it contributes is count of 0 after this. So in this case, like, probably let's just say that let's say this is a sequence. And now we are comparing what happens if we change this one to 0 and what happens if we change this one to 0. If we change this one to 0, like, if you see, like, this is one inversion pair, 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 and this is one inversion pair. So this one is a part of 5 pairs. And if you look at this one is a part of 4 pairs. 1, 2, 3, 4. So if we have to be greedy here, then it's always better to change the one which comes first rather than any element at last. If we change 1 to 0, then choose the first one present in the array. Can I say this? Because here if we look at this one is a part of 4 pairs, but the one before it is a part of 5 pairs. Like, the number of zeros after this will always be higher. Like, if we want to change some 1 to 0, then it's better if we find the first one present in the array and change that to 0. Because if we look at first one and second one, because this one contributes all the pairs which have number of zeros after this, first one will have higher or less zeros from the other one. So any questions on this one? Like, this observation is a bit critical here. Yeah, like, I am not claiming what should be the 1s or 0. What I am saying is, let's say if we end up deciding changing from 1 to 0, then we should always choose the first one. I am yet to comment about how many 1s we should change, how many 0s we should change. So smash itnam, yeah, like, your example is correct, but I am yet to reach at that observation. And similarly, I will say, if we change some 0 to 1, always choose the last 0. Like, the idea is similar. So, like, we have made 2 observations. We have some sequence given to us. Let's say we have changed, for 5 times we have changed 1 to 0, and for 10 times we have changed 0 to 1. So based on our previous observation, we know that we should remove the first 5 ones. Let's say 5 ones are here. And we should also remove the last 10 zeros, nothing else. Like, so in the prefix part, everything here would be 0. Because if you look at all the elements until the first 5 ones, Some of the zeros were already there and some of the ones you have changed to 0. And in this suffix part, you have changed all the zeros to 1. So like everything here would be 1. And like this would be some unchanged part here. And you notice like now you have sequence which looks like this. You have some bunch of zeros in starting, then you have some unchanged sequence, and then you have some ones later on. So the number of inversions in the sequence is equal to number of elements in this range, number of inversions in this range. Any questions? Looks better, right? Yeah, like I also tried, by the way, two pointers, but I had one bug or the another bug there. Then I ended up doing something else there. Yeah, like there would be way to do it. Like so now what I will do is, yeah, like 1 second. So like my idea is like I will fix number of zeros change. Hello, hello. Like, am I audible now? Like, my light just went off. So like I did not had internet connection for a minute or so. Yes. Okay, am I visible enough? Like, is audio and everything fine before we get started? What about now? And like there is always two toggles. Like I'm hopeful it should be good now, but if I get one heads up from the chat, I will continue with my discussion. Hello, hello. Okay, are there still some problems or everything looks fine now? Hello, hello. Is it fine? Okay, restarted. Hello, hello. Hello, hello. I think the audio and everything should be better now. Yeah, okay, it's working now. Okay, let's continue. So what we have seen so far is, now I will fix the number of times I will change 1 to 0. Let's say I will change 5, 1 to 0. So like, to make it a bit greedy, if I change 5 ones to 0, then I can change k minus 5 zeros to 1s. Looks fine, right? And now I will keep changing this number. I will iterate on, I will change number of times I change 1 to 0 from 0, 1, 2, 3, 4 up to k. And my idea is, based on where 1 is present, I can find the fifth index of 1, and based on where 0 is present, let's say k is equal to 15. So I can also find the 10th last 0. And my solution would be to count the number of inversions in this sequence now. And this is my main idea. Like, I iterate on number of 0 to 1 from 0 number 0 to k, and like there is no point in changing some number from 0 to 1 and then back to 1 to 0, because here you are just wasting two elements here. So the idea is, let's say I will change 5 times from 1 to 0 in starting, and if my k is 15, in that case I should change last 10 zeros to 1. And I can do something better for, like, since I'm iterating on all the values, another case I want would be like, I will change the 3 times 0 to 1, and then I will change 12 times from 1 to 0 at last. So based on like the third index of 1 and the 12th last index of 0, I can get a range in which which will remain unchanged. And my idea is to use segment tree solutions to count number of inversions in a segment there, and just take minimum of all the segments here. So that is my idea. So like, now my problem has reduced to, I have a binary string and I have some ranges over here. This can be one range, this can be some another range, this can be some another range, and I have to take the minimum of all of such possible ranges here. Any questions so far before we solve how to count the number of inversions in a range? So like, there are no counter test cases for 2 pointers. Like, 2 pointer is supposed to work. It's just that my implementation was not good, so there were some bugs left and right. It is possible to solve using 2 pointers. So any question so far, like how we have reduced the original given problem to counting like the number of inversions in a range for the given string, and now we have some different ranges, so we need some way to query number of inversions in a range. If this part is clear, I will move on to the next part for this problem. No, like that's not necessary. Like, I can just share a counter test case like for developer party your solution. Let's say a sequence is like this: 1 1 1 1 0 and k equal to 1. Here if you change this 1 to 0, number of inversions are 0. If you change this 1 to 0, then number of inversion will still be 3. So like, there can be cases where you have to remove some prefixes. Yeah, now we need to find L2R and number of inversions in it. So the idea is, let's use the segment here where like we have, let's say, L2 mid, We have mid plus 1 to R. We know number of ones here, number of zeros here, and total inversion count in this segment. We also know number of zeros here, number of ones here, and inversion count here. Now if we want to look at the complete L to R, O1, L1, INV1, O2, 0 to INV2. Total number of ones here would be O1 plus O2. Total number of zeros here would be Z1 plus Z2. And my claim is like total number of inversions here would be number of inversions in this part, which would be INV1 plus number of inversions in this part plus the some 1 from here and some 0 from here. So like the number of inversions across these two boundaries would be O1 into Z2. Any questions here? Like that is like basically if I want to count the number of strings in a segment tree, if I know number of zeros in the left part, like how can a segment look like? Either 1 and 0 both are present here, or 1 and 0 both are present here, or 1 is present here and 0 is present in this part. So like all the pairs like this would already be taken care of in this INV count. All the pairs like this would be taken care of in this INV count, and all the pairs like this would simply be number of ones in this part multiplied by number of zeros in this part. And like this idea, like it's not order n square, and like this is the idea, like that is how you build a segment tree build function over here, and you will be able to solve the problem. If I am choosing 1 and 0 with same number of inversion, then we must choose 0. Why that greedy will like for greedy, like we will have to probably look at each one of them, like there should be way to generate counter test cases against them. And like that is the overall solution for this problem. Largest scale is done, and like what is the code for this problem? Minimize in count. So like we are in segmentary node. Let's maintain a strut. INV count. So if we have left part, then total number of ones would be A1 plus B1 plus number of zeros would be A0 plus B0, and total number of inversion would be A INV count plus B INV count plus the number of inversion, which would be A1 multiplied by B0. This would be like how you write segment tree for the inversion count. For the sake of simplicity, I ended up adding 1 0 and starting 1 in the end. Like it does not make any sense. But yeah. Let's find all the indexes of 1 and 0. If any of these is less than k, if number of zeros are less than equal to k, or number of ones are less than equal to k, then we can just change all of them and put 0 here. And this is the idea. Now let's fix the number of zeros to 1. Number of 1 to 0 would be k minus 0 to 1. And like what we will need is 0 to 1 should be done at the last index. One to 0. If this left part is right, then the answer is 0. Else we can take answer of minimum from L to R. L plus 1 to R, we should not include this. And this would be the solution. And this would be my solution for this problem. We can initialize answer as initial inversion count. Wait, looks like I messed up some bug somewhere, but like this was the main idea. 1 second. Like if I'm changing from 0 to 1, I have already removed. Like this is the main solution, but like probably I have some bug somewhere, or I don't know. This is how my solution was over here. Like what I did was, like instead of finding these boundaries, I ended up just doing binary search and fixing the left part. Like there is some mistake somewhere with respect to calculating boundaries here, but in the interest of time, I will probably leave that for now. So like this was the original solution. Like I started from some IDX left to right. I counted number of ones. If number of ones which have been changed in the prefix is greater than k, just break here. Otherwise, like number of zeros we need to change, we count. And if the suffix is less than that count, answer is 0, break. Otherwise, I ended up doing a binary search on up to what I can go there and made some changes there. But I will probably leave this idea somewhere. Any questions over here? And like essentially this is the solution for this problem. 1 0. Okay, wait, this is the problem. Okay, like n cube can be because of weak test cases, but definitely not something that is supposed to pass. 1 0 0. Like probably I am messing up somewhere with respect to these boundaries. So in the interest of time, I will skip debugging here, and like this is how the main solution is. There can be some off by 1 boundaries here, but I am planning to skip. First 1 0 invert count, 1 0 invert count equal is 0. If x is 0, second element should be placed, second is 0. If x is 1, first element should be replaced. Then a segment tree on this. Initial answer is original inverse count. Like there are some things which I have matched over there. Okay, I will just submit it. In case there are some WLs, I will probably move on to the next problem anyways. Probably let's just move on. Like this is how the solution structure is, but I definitely have some bugs in the inversion. And essentially, like this is exactly how this function is defined. L0, R0, L1, R1, left inversion, right inversion plus L1 plus R1. So yeah, like this can be a good practice exercise here. So any questions on this problem before we move on to find P and counting is fun? Like drawing board, I am using Xcali, and then I have a writing pad there. Yeah, looks like some people have some order one method to calculate number of inversions from L to R. There might be some solutions, but yeah, and like it would be fun if you can just add those solutions in the comments there so that other people can refer to them. Okay, I will move to the next problem, find P. Like probably if you can just paste your submission ID, I can look at that DP solution because like at least I don't have all the formalities required for the DP part here. So it says you are given three integers n, l, and r. You have to find the permutation of length n such that number of, if you look at the prefix sum of that permutation, then the number of elements between L to R is as small as possible. And if there are multiple such permutations, you can print any of them. That is what the problem statement is asking us. So like it says, we are given integer n, L, and R. And now you have to find a permutation P1, P2, up to Pn. Permutation means all the numbers from 1 to n appears only once and exactly once. At least once and exactly once. Such that if you look at its prefix sum, first element would be in the prefix sum P1, second element would be P1 plus P2, third element in the prefix sum would be P1 plus P2 plus P3, and so on. And the last element would be sum of all the numbers. Then if you number of elements which are between L to R in this array should be minimum possible. So like it's a constructive problem. And to be honest, I did found this problem a bit hard. Like I did some brute force stress testing and then I tested some ideas there. And I can say like what I implemented, which got an AC, and like I stress tested it, so I was near that that idea would probably give me the correct answers, but I did not had any proof why that is the only solution. So I can share my idea like what algorithm I used, but that may not be the only possible algorithm there. And why it gives correct was mostly because I got an AC rather than I tried to formally prove it. So any questions on the problem statement first before we jump on to the solution for this problem? Okay, so what I did was I started putting the smallest number first, like 1 first, 2 first, 3 first, 4 first, up to, let's say, I have added some number k, such that now the sum of first k number is greater than equal to L. This is the first thing I did. I inserted numbers in increasing order and I kept doing it as long as my count was less than L. Now the sum of, let's say, this number is S. And because then what I did was I tried to remove one number from here. So that sum becomes L minus 1. Like sum of these first k number would be k into k plus 1 by 2. Like k, like I am adding number from the smallest as long as like the sum is less than L. And once my sum becomes greater than equal to L, I remove one of the numbers from here such that sum becomes L minus 1. That will definitely hold because until the k minus 1, sum of numbers was less than L. And once you added k, only then you have crossed the boundary of L. So whatever delta you got over here, like let's say this is where the R is. So this delta would definitely be one of the numbers here. So I found that number and deleted that number. Let's say this number is 4 minus L minus 1. So like basically I created one array of numbers from 1 up to some number k where only one element is missing, such that this sum is L minus 1. First thing first, one element is missing here, so using k minus 1 numbers, this sum is L minus 1. Then the next idea is, then I started putting numbers from the highest to largest, like n minus 1, n minus 2, and so on up till all the numbers up to k plus 1, and then deleted element. The idea here is first you go up to L minus 1 and then take the maximum possible jumps you can get. And that is the solution I coded, and that also got an AC here. I can share my code, but that is what I ended up doing. The problem is stacked. First, all the numbers which I have so far, as long as I have some one remaining number, find the smallest number, insert it into the permutation, make it to the sum. If current sum is, this is not required. If current sum is less than L, continue. Otherwise, if I remove earlier this, I don't even need this as well. Now, whatever sum I have, subtract it from L minus 1. Like this is the element I should remove now. So find its index and erase it from that permutation and insert it back and remove it from the sum as well. Now your sum is exactly L minus 1. Now just insert all the numbers in decreasing order over here and return the permutation you got. That is what I did was I ended up stress testing it a bit. You can probably refer this code. I can probably paste this in Zoom or somewhere to just test out a brute force which runs on all permutations, count the minimum numbers. This is permutation, and then try out or L to R, etc. Like that's how I ended up testing my code. Like this algorithm indeed gives minimum for at least the small values, if not large. And like that was the solution I had. Any questions on this problem before we move on to the next problem? This is the algorithm. Like first, keep adding smallest number, and when you get just more than equal to L, delete one number to make sum exactly equal to L minus 1. Now insert number from the largest to smallest. And this was my algorithm for this problem. Any questions on this one? Why this work is mostly proved by AC. Like I did not formally try to prove it. Just tested it on small test cases and I found that for all L to R and for all n equal to 7, 8. This is giving me the right answer. So next problem, last problem for today would be counting is fun. Any questions on this problem before we move on to the counting is fun? So counting is fun. It says you are given a positive integer n. Find the number of arrays A of size n such that there exist two permutations P and Q, each of length n, satisfying AI equal to max of Pi Qi for all 112. Number can be large, so count it with some modulo. So what it says is, like, let's look at all the, like, there are n factorial permutations here. So let's look at all such permutation E, and for all such permutation Q, total n square such permutations. We will create an array A where AI would be max of AI comma BI, PI comma QI. And it asks us to count how many possible different A you can get. And like that is what the problem statement is. Let's look at some examples here. Like I can in fact show you all the sample examples of A you can get. Counting is fun. Only brute force 2 is what I will be naming it. Yeah, like I will clear the statement once. What it says is like for a given n, there are n factorial permutations, right? So you take any two random permutations from them. One is Q, one is Q. And now you create an array A, which is maximum of element at that index. So for example, if your P is 2, 1, 3 and Q is 1, 2, 3, for first element take max of 2, which would be 2. Second element take max of 2, which would be 2. And for third element take max of both the elements would be 3. So your final element would be 2, 2, 3, something like that. So it problem statement asks us to count how many possible different A you can get. Because you know, like your sample size is, there are n factorial permutations for P, n factorial permutations for Q. But like there can be some combinations which gives you the same value of A. So you have to print like the number of different A's you can get. So like for example, I ended up generating some samples for 3. So for example, if you take 231 SP and 213 SQ, then if you look at maximum at both the places, for the first element it's 2, for the second element it's 3, for the third element it's 3. So A you have got is 233. And here also you got A equal to 233, where the other permutation is 231 and 123. So that is what the problem statement is asking. Any questions on the problem statement? So the next idea is simplification. Like we know that AI is max of pi comma qi. And because p and q are permutations, every number appears at least once, every number appears only once. So any number in A can appear 0, 1 or 2 times. 2 times when so for example, let's pick 2, 3, 5, 1, 4 and 4, 1, 5, 2, 3. Let's say this is P, this is Q. So A here would be 4, 3, 5, 2, 4. So here 1 does not appear anywhere because 1 has been paired in both the permutation with the number larger than this. 4 appears 2 times because the other time it was paired both the numbers were less than this. And 5 appears only once because it was just paired with 5. Let's say, in fact, it's also possible to get some different pairs as well. Like let's choose some other permutation as well. 5, 3, 4, 3, 3, 4, 2, 4. Like I'm just trying to create some permutations here. 4, 2, 1, 5. What is the missing element? 1, 2, 3, 4. 2 is missing here and 1 is missing here. So overall A in this case you will get is 5, 5, 4, 4, 2. So some elements appear 0 times, some number appear 1 time and some number appear 2 times. Like is this observation clear? Like the number can only appear 0, 1 or 2 times, not more than 2, because a number is only like it appears 2 times when the other number it has been paired with both the times is less than equal to that number. It appears 1, then once it's paired with 1, once the number higher than it, once the number less than it. And like 0 if both the times it was paired with some number higher than that. Any questions on this? So like now my idea is, let's try to simplify this. Like I would say if number appears only once, if it is same both the times. Like in A, if a number up here it is, let's say 2 has appeared only once, right? So I will only create permutations here. Like a number should appear only once if both the time it was paired with the same number. So like another possible way to rearrange here would be 2, 1. The A is still same here. And in this case, you see the number has been paired with itself. So that is what I am trying to do now. 0, 1, 2. A number appears only once if it was paired with itself. Like my idea is, for any other combination, you can rearrange some numbers in a way such that they appear with itself. The logic for 0, 1, 2 is like, if you look at overall count of numbers, every number is there only 2 times, once in P and once in Q. So like when you take max of 2 numbers, if both the times that both the places where that number was higher, then it would appear in A 2 times. If once it was higher, once it was lower, then that number would appear only once. If both the times it was lower, that number will not appear in A. And the idea is like you will always be able to do some combinations like this. Also, for example, if you look at this pair, like 3 appears only once, right? So you can remove this one, bring this 3 here and remove this 1 here. And the A is still same. So that is what I am doing first. If I am looking at A and I have see what all numbers have appeared only once, what I will say is like on the original P and Q, I can rearrange numbers in such a way that all the numbers which were appears once, they were paired with themselves. And you can probably work out with some examples and you will realize this observation. The next thing I did was, like for all zeros and ones, keep same combination. So for what I mean to say over here is like, here now we have changed this 2 to make it 2. 4 is paired with 1 here. And here 4 is paired with 3. What I can do is, I can remove this one, make 1 here and make a 3 here. So that 5 is always paired with 3 in both the times. And 1 is paired with 4 in both the times. Here also like 5 appears only once, so it's paired with itself. Here like 1 is paired with 2, 4 is paired with 1. 4 is paired with 2. Did I mess up somewhere here? No, right? Yeah, what I can do is like 5 is paired with itself. It was 1 and 2 pairing, right? So I can remove this one and bring a 2 here and keep a 1 here. The max is still same. And I can do with the same with 3 here. Next thing I am trying to do is, like all the remaining number appears 0 and 1s. Like let's say we have 1. These are the numbers we have. Let's say we have decided 2 and 4 will appear one time. So at the place where in A, if it's appearing 2 here and 4 here, then what I am saying is, in P and Q, keep both the places as 2. And for all the remaining pairs, let's say 3 and 6 appears. In a place like this, 6, 6, 3, 3. So my idea is like pair 3 with one number less than that and 6 with one number less than that. So here make 6, 5, here make 5, 6. Here make 1, 3, here make 3, 1. That is basically, instead of taking n factorial possible choices for P and n factorial possible choices for Q, I am looking from reverse. I fix some segment A and I try to form the pairs using, like I try to see if I can get some P and Q such that that is the array which. What I am doing is, I am first deciding an array A and then I am trying to see can I get some P and some Q for that A. And the way I am doing is like, first look at all the numbers that appear only once. So for both P and Q, form the same number there. And now you would be left with some numbers which appear 0 times, some number will appear larger time. So the idea is you pick the largest element which appears 2 times, largest element which appears 0 times. Form a pair for that, which would be 6, 5 here, 5, 6 here. Here like first I formed a pairing with 6 should be appear 2 times and 1 should be appear 2 times. So I chose 6 and chose 5. And everywhere like 6 was present. In one permutation I wrote 6, 5. In another permutation I wrote 5, 6. And now like 2 was also appearing 1 time and 1 was appearing 0 times. So for this pair like 2 need 3. 3 was appearing 2 times and 1 was appearing 0 times. So at 1 where 3 is, write 1, 3 and at 3 write 3, 1. And that is what my idea is. Yeah, I have some n numbers. I will choose some NC1 numbers which appears only once. and then I will choose NC1 positions for them, and I will make them these many times. I will put them there. Next, I would have some T pairs remaining left. So like T by 2 would be appearing 2 times, and T by 2 would be appearing 0 times. So like I will form one-on-one pairing with them, and then for every 0, like I will use the same. For every number which appears 2 times, I will just keep 3 5, then 5 3 pairs like that. So like this part is easy. You choose what numbers you want only once. You choose at what pairs you want all the numbers, and you arrange them in the array. For this T by 2 pairing, we cannot directly choose any random number, because if you see like 1 3 5 6, it's not possible to make 3 and 5 2 times, because 6 is the highest number. Wherever 6 goes, it would be the largest number. It's not possible to have a combination like this. So like the idea is, if you arrange all the numbers which appear 0 or 2 times, 6 5 3 1 in this case, then in that case, like if you say you write +2 for the number which appears 2 times and -2 for the number which appears 0 times, then this prefix sum should always have a non-zero number, because like this 6 can be paired with any number here, and whatever remaining number should be paired with the smaller number here. And this turns out like it's equivalent to counting the number of valid bracket sequences over here. This can be one way. 6 is paired with 5, 3 is paired with 1. If this is the bracket sequence IF, it means 6 is paired with 3, 5 is paired with 1, and so on. So like, and counting number of valid bracket sequence is Catalan number. And like now you will have to also deal with putting 2 2 there a bit. Like reinterpreting symbol, like a symbol like Cn is the length of 2n sequence, where a sequence of nx and ny, that no initial segment contains more y than x. Like basically, if we look at y as the number which appears 0 times and x as the number which appears 2 times, then for every 2 there should be a paired 0, and because it appears 2 times, it should be more times here. So we can directly choose the Catalan number there. And because and in this case, like we will have to also deal with like the pairing, like 6 6 3 3 is valid pairing, 6 3 3 6, and so on. Overall the sequences here would be like 4 factorial by 2 factorial 2 factorial possible sequences there. Like for each number you choose 2 2 2 2, and like that is how the numbers would become there. And that is my solution for this problem. Count the number of ones which appear from 0 to n. The rest count would be n minus 1, because every 2 will come with a pair of 0. So if the remaining numbers are odd, it's not possible. Otherwise 2 and 0 would be rest by 2. First, I select the numbers which appear at once and the index where they should be present, and number of ways to arrange those numbers. Now the number of ways to form a valid pairing is just the Catalan number. This is pair count. This would be number of valid ways which using which we can form the valid pairing count, which is Catalan number. And like then the number of ways to arrange these valid numbers, which would be factorial into 2 times pair count divided by m int, and overall this is the solution for this problem. No, like hard problems sometimes do involve DP and all. So I think with this I'm mostly done with my stream. Any questions related to any problem from this contest or any general advice or something which you guys want me to answer before we call it a day today? Yeah. Like for example, some people were asking some resources for DP. So like these are mostly most frequent asked questions to me. So like I ended up writing answers for the most frequent questions on my Discord server. So like you can probably find Discord server link in the chat. Here there is a channel roadmap to read in 2 minutes. Where like the question, like if you are looking for standard problem on say topic X, like X can be DP or any other thing. What you can do is you can read this USAV guide. Here it's you can search for DP here. There are many variations of DP. Or if you want to go with your level, you can also choose bronze, silver, gold, platinum. Roughly speaking, bronze is Div3, Div4, and platinum is harder than Div1. So let's say you have chosen Div1. Then there are many problems with many topics here. So in gold division, there are 356 problems marked here, modularized. So if you are looking for range DP, you can look here. There is some tutorial over here, some sample problems solved over here, and a list of problems here. So like the way to probably solve this is like you should know some topics which you want to read and then search for it. Or if you don't want, then you can probably start with the division and then go through the topics one by one. And for each topic, solve some non-zero problem. Another way is like CSCS problem set is also there. It has around 200 or 250 problems marked in different topics here. Like a lot of editorials are there already on YouTube, so you can search out if you are stuck somewhere. And if you want to read something, you can read this CP Competitive Programming Handbook here. Any resources, like the problem with Project Euler is like there are no solutions available apart from first 100 problems. So like for first 100 problem, you can probably try them out, and for harder, like it's like I prefer solving problems which have an editorial, so that I am not stuck on it for infinitely long time. And probably I don't have anything specific for mathematics. Probably the way to do would be try out standard problems. And like one advice which I do to people is you should always participate in AdCode beginner contest if you are just starting out, because that is where you will find standard problem and the contest is also rated, and rating is always a motivation to perform better. And then I have also advised on like what I used to do when I was less than equal to expert, like when I was targeting 2100 rating, etc. and everything. And like a very best advice from Omnic is to get better at X, you should do X. And X can be anything: DP, maths, combinatorics, permutations, anything. Okay, Satyam is here. The problem was like I did like the contest, and like the counting is fun was the problem that I liked most. Like because like when I realized that number is just equal to the Catalan number, like it just blew my mind. Any good C++ project recommend site to search for this topic ideas? Like if you want to make development related product, like I would not advise coding them in C++. Rather, probably choose some tech stack. Like generally, I choose Go because I write in Go when I work. But you can probably use Java, Springboard, or if you are doing something front end, then React or something. Or like the first project idea I would give anyone is to create a website on your own. Like I created a domain quite a long ago, but very recently I have my own website. Like I took this domain around 5 years ago, and around 2 weeks ago I ended up creating a website. I will add some more blogs here, and I am planning to use this website as a supplement for my video editorial. The first thing which I am trying to do is like a lot of people ask me what is my competitive programming setup and how to use Edcode or library offline. So like probably when I am not lazy enough, those two would be the first two videos that would be out. Okay, have you tried for Google? Like I did once when I was just starting out 3 years ago, like on campus or something. Like my test did not went well, and my CGPA was also too low back then, so I was not shortlisted. And after that, I did not try again. Like I'm pretty much happy with what I have right now. So what are you doing apart from CP? Like I work from a 9 to 5 job. So yeah, project ideas for placement, like probably like that choose some text like not something the key I have. Like when I was trying, like I had some two projects which I did. Where is GitHub man? So like I did created this one remind board. This auto tester was from my course project, and I had some contribution on this TLE board as well. And I think these were pretty much the projects I had back then. Okay, Quant 3. Like sometimes Secretor did reach out to me, but I was just happy with whatever I'm doing right now. Like Quant is not my cup of tea, I would say. Like probably I avoided it when I was just starting out because I wanted to try software development. And after that I did not try it. Like I never applied for a quant company, to be honest. So definitely I don't have any advice. Like my role is mostly software development. Like in day-to-day work I mostly work in Golang, and probably there are some high data center like big data storage like Cassandra we use, and MySQL for a few small stuff. So I think if there are more questions in the chat, I would be happy to answer them. Otherwise, I think I will end this stream now. And thanks everyone for joining today and still bearing when I had some electricity issue.